For the last chapter, we'll discuss about optical device and memory device. First is optical device. So before understanding the optical device, let's start from the understanding the absorption and emission. From the basis class, we learned about that energy band diagram. So this is conduction band and this is valence band, and between conduction band and valence band there has a band gap. And the band gap means neither state and carrier doesn't exist. So under the valence band there has electrons from here, and conduction band there has a state that electron can exist, but if we don't give an additional energy, there hasn't exist some carriers. So if we give some energy from this device, and then the electron can be excited to conduction band, from valence band to conduction band. And from this energy we can give light, optic energy, and we can also give electric energy and thermal energy. So when the carrier excites from valence band to conduction band, we can call this absorption, because if the carrier goes off to conduction band, it have to absorption the energy. And there has another case is emission case. The carrier already exists from the conduction band, and the carrier has recombination from the valence band, so we can call this emission. Because by recombinate the electron, they emit some energy such as thermal energy or optic energy. So we will use this optic energy as an optical device. So by using the absorption, we can make a photodiode, and by using the emission, we can make a LED or laser. So as I told that the photodiode is made by using the absorption. So if we give some energy from the device, optical energy from the device, it can make a current from here. This is the principle of the photodiode. And LED is by emitting the optical energy, so we can use the light emitting. And let's see the memory device. The memory device has there has a various memory device from now, but from now we just see only SRAM, DRAM, and flash memory. The memory can be consist of the volatile memory and non-volatile memory. And for SRAM and DRAM case, it is a volatile memories, but flash memory is non-volatile. So let's see how the SRAM, DRAM, and flash memory works. For the SRAM, the structure consists like this, and there has a word line and bin lines, and it consists of 6 transistors. So we can call this structure 6T 1 cell. It means 6 transistor 1 cell. So when we write 1 from the SRAM, we give a 1 from bin line, and we give 0 from bin line bar. And when we give a 1 from word line, the transistor M6 and M5 turn on, and from their M2 and M1 bias is turned on, but the M2 transistor is PMOS and M1 transistor is NMOS. So M2 is cut off and M1 is turned on. So the output can be 0 from here. So if we give a 1 from word line to sense amplifier, by the latch structure, there has a one data from here, 0 data for here, and the data keeps until we rewriting or reading. So this is the how to work the SRAM. And DRAM is structure is 1T, one cell structure. So the data saves from this capacitor, but there has one problem that the capacitor has a time to consuming the data, so we have to refresh the data if we want to keep the data for a long time. So if we want to write the 1 to DRAM, we give the 1 from the bin line, and when we turn on the word line, the transistor has turned on and the 1 is saved from this capacitor. And third memory is flash memory. The flash memory is similar to MOSFET structure, but different thing is that there has a more structure from the gate. So we call this a tunneling tunnel oxide. And here is a floating gate, and there is a blocking oxide, and this is the gate, control gate. And we usually use the double-doped N-type source and drain, and substrate is P-type. So when we give a gate bias from here, and when the channel has made it, there has an electron from like this. But when we give a gate bias, the tunneling oxide goes thinner, so the tunneling effect is evoked. So there has a electron from the floating gate. So we can save the data from the floating gate, so we can use it by a memory device. This is the principle of the flash memory.